Welcome back, folks. Time for another talk. This time, I'm being joined by Roberto to talk to us about serverless containers with Azure. Roberto, I won't waste any time. Take it away.
Yeah, thank you, Darren. Okay, let's go. Thanks to be here. And today, for whom already knows me, I would like to share my thought about the continue of my journey around containers. So this slide, as you saw, is there's a strike through because I started a few years ago with 100 machines do 100 seconds working 1 second, meaning that I used a service to scale up more my needs. What were my needs? My needs to compute messages, compute million messages, and manage big data flows inside my architecture. Okay, and a year ago, I presented the way to scale up containers with the ACIs, and now I'm here to share my thoughts about a complete serverless approach to container with Azure, with both container instances and container apps. That is a new thing that came out like 6 months ago, but went in GA, in general availability, just yesterday or 2 days ago during the conference that's name is Build, around Microsoft stuff and news. Okay, so okay, this is my personal point of view about compute in Azure, and so it's not the magic quadrant and something like that. It's just something mine. Okay, I really believe that this kind of services can split between the capability to scale better compared to others, and the ease of management. So what I mean with ease of management, so the degree that we need to spend around the service to make it scale or to govern it, to manage it. Okay, so to make an example, for me, VM is the lowest point possible, so it's hard to scale and hard to manage. While, for instance, app service, if you already know, in Azure, there's the engine to run web apps, to run web jobs, is really easy to manage. It's really easy to manage, but it's not so scalable because you have just an hard limit of 10, 30 machines, even 50 in some environments. Or you can use function that is really scalable, but they have some pitfalls in management. We can use batch, that is like a series of VM that you don't see, so really good from the management point of view, and really good in terms of scaling. And we have container instances, that is this technology that make you run your own container in a serverless approach. Now with this new thing, we have container apps that, in my opinion, is not really ready from the scalable point of view, but we will see it later in the session. But is definitely the best things I found in terms of management and in terms of serverless container. Okay, so this was my personal timeline in this last 3 years, something like that. Okay, I start with app service, running my workloads with web jobs. So for instance, just to give you some context, I need on a daily basis to process million messages in an event driven architecture. So when I process a message, I perform things and the message will be completed and next. Okay, so I started to run that workloads, that actors inside web jobs. Then I needed to scale up more, and I use batch, but batch is around VM, so it's not really easy to govern. Okay, and then I moved to container instances, and we are already in that part, and we are transition to container apps that, in my opinion, is the next big things in Azure. Okay. So now the slides are finished, and I'm ready to demonstrate all the stuff I prepared for this demo. So the starting point is just a simple producer consumer app in .NET. So this is the only starting point, and everything we will build it from scratch. Okay. So what I mean with consumer producer consumer app, let me a second. We have a producer that is connecting to a service bus queue and is writing messages 1 per second, and a consumer one that is connecting to the same service bus that is consuming message 1 per second. Okay, so not really hard to understand, and this delay is to simulate a sort of uh, rate, okay, a throughput, way to govern the speed, okay, because they are simple messages, but in real world, a message can hold like a logic that we need to perform before completing it. Okay, so let's create the resources we need inside Azure. So we start from scratch. We need, of course, a service bus. So let's create it inside this resource group. Service bus. Okay, what is a service bus? It's a message broker. So if you know Rabbit, for instance, MQ, if you know not really Kafka, it's quite different, but it's just a message broker. Okay, so DevOps conference, DevOps Europe, okay, DevOps Pro, okay, 2022. Okay, West Europe, and the pricing tier. If you see a big difference between these tiers, is because the premium one is a completely different architecture that is so scalable. But for this demonstration and also for most of the workloads, you can use the standard one that is very cheap. Okay, so let's create this one. In addition to this service bus endpoint, I will need a container registry to hold my instances. I could even publish them to Docker, to Docker Hub, but I want them private. So I will create another container registry here that is just for me. So even this one is up 22. Well, okay. In Western Europe, I'm accustomed to create some things in Western Europe that is actually like Amsterdam, okay, something like that, because of the latency from Milan, where I live, to Amsterdam. But it's, of course, up to you to choose your region, your data center. And they are also opening one region in Milan, so I probably will switch some services here. So it's not needed to customize this stuff. And let's create also the container registry. Okay. In the meantime, the service bus is ready, so we can go there and we can create a queue. Okay, a queue is like a first in, first out queue. Okay, so you can publish messages and receive messages. So it's not a session about service bus that is really complete. It's really complex from a point of view, but complete is a good thing because we can have publish subscribe messages, we can have dead letters, we can have duplicate detection, we can have a lot of things. Okay, but now we are just using a simple plain old queue that we are naming messages. Okay. And I would like to open a monitoring part around this queue that now it's empty, of course. So let's monitor the active messages. Okay. In the last 30 minutes. Okay. And let's keep this one open. Okay. So good. We are almost ready. So I would like to have the connection settings about the service bus to use it in the application. So I take the root connection settings. It's not really a best practice, but you can customize it, of course, in production, in real world. Okay. So here is the connection. Here is the name of the queue. I build all the stuff. I have a window open in the other screen with the binaries. So I'm running the producer. Opla. Okay, the producer is producing and the consumer is consuming. Okay, really simple. Okay. This is not the core of the demonstration, but this is a producer that is producing with a rate of 1 per second, and a consumer that is consuming 1 per second. So now the situation is really stable. Okay, so our queue will have around 5, 10, 20, I don't know how many, but few messages active in the queue, because the ratio from between producer and consumer is stable and it's equivalent. Okay, but of course, if I'm increasing the producing part, adding another producer, okay, of course the single consumer cannot consume the messages with a good ratio, so the queue count will continually increase. And this is also known as, in some cases, starvation at the extreme. Okay, so if we have like a 10 producer, just one consumer, the consumer is not able to consume the messages at the proper rate. Okay, good.
Roberto,
Yeah.
just one small thing. When you're like doing the coding in the background, could you maybe make sure you're zoomed in a bit more, because some of the viewers they can't quite see what
Okay,
you're
like
typing.
this.
Yeah, that's perfect. Thank you very much.
Okay, thank you very much, Darren. Okay, that's perfect. So well, we can also stop that stuff. Yeah, we can see something moving on the Azure part. So I'm expecting to see something here. Okay, the queue count is increasing, but just like 7. Okay, it's not really important. I will zoom it also here in Azure. Okay, now, well, that's too much. Okay, so now let's publish that stuff on a container. So let's publish the consumer part on a container. Okay, to do that, I prepared the Docker file that's just saying, okay, starting from that image, build the stuff and run the consumer part. So the consumer part stays here in this path. Okay, and I will publish it to the container registry. But before, I need to log in to the container registry. That is no, that is here, but this isn't refreshed. Okay, this one. So let's duplicate this to work on it. So to log into the container registry, I can use this username and a plain password. In production, I suggest you to use the integrated Active Directory login. That is better. Docker login dop22 azure.cr.io. Okay, I wrote it correctly. Yes. And the password is in my clipboard. Okay, good. Now I'm building, well, it's the right folder. Yeah. So Docker build tag dot 2022 dot azure.io/consumer point. So Docker is building, using the Docker file, is building all the stuff in the actual folder. And now I'm pushing this image to the cloud, the container registry that I just created. Let's wait a few seconds. Okay, almost done. Good. So I'm expecting to see here, okay, my container, my image. Okay, so with the image here in the cloud, of course, we build it manually. We build a Docker file, so we can do this part. We can do it in several ways. So we can automate it with DevOps. We can have some pipelines. Okay, in production we actually have it. Okay, but for the demonstration purposes, it's better to stay lighter and easier. Okay. So now let's create the container instance. Okay, so ACI. Azure container instance is see it as a way to run a Docker container without Kubernetes, without all the SL to manage the orchestrator. Okay, so let's focus on this creation part, on this wizard, because it's really chatty. Okay, so DOP 2022. This is the name of my ACI. It's not it's something that it's up to you, to us, of course. I would place it in Western Europe, and I'm telling the engine to use a container image in my container registry. I don't have one. No, it's really impossible. Okay. Well, good. So let's try to do this again. Okay. Let's go ahead. Nice. Okay, let's press Control F5. Nice, really nice. Okay, well, give me a second. Okay, no problem. Let's do it manually. So, few seconds more. Private image consumer login server is this one. Of course, this was not expected, okay, because everything should be integrated, but we don't have time to troubleshoot it. So let's go with the manual approach. Okay, and what slash latest. Okay, let's hope it works, because it's really unexpected. Okay, and by specifying my image, I will tell the engine to run it inside this container instance. This is a very important part. Okay, by default, the underlying Kubernetes instance will restart the container in case of failure. Okay, this is a really good point, because if your Docker container will fail, it will be restarted and restarted and restarted. But if you want also to restart in any case, for instance, your code inside a container could also end in a gracefully way, okay, like a run to completion mode. Okay, in that case, you can change the behavior to always, or even never, if you want that the container can stop after its completion. It's also an approach, because keep in mind that the container instance, if it's stopped, it doesn't bill, it doesn't have a price, it doesn't cost anything. So it's really good point to say, okay, if I complete my work, I cannot pay, I don't pay anymore. Okay, let's hope it works because of this trick. I think so, because you can integrate every container registry, but I'm accustomed to use I'm accustomed to use DevOps with the pipeline, but in this case, I'm accustomed to use the drop downs and the suggestion from Azure. Probably it's working because of the time, and I don't notice any failure. Okay, in the meantime, let's see it. Okay, it's creating. Okay, good. Let's see. Okay, the container is running. Okay, and we see some logs. It's okay, so it's working. This is the container instance. So an artifact, okay, that is running. It has a performance target of 1 CPU and 1 gigabyte of memory, but you can increase it up to 4 CPUs and 16 gigabyte of memory. And in this personal, where is it? Okay. In this log, you can see the logs. It's not really a streaming part, but we can see the log. And of course, if we restart again to produce, of course, we will see it. A few seconds, maybe. Okay. But I hope so that we will see it in action in some seconds. Okay. But the starting point, the idea behind this demonstration is to scale. Okay, so just one container instance, it doesn't scale. Okay, so I need to create more, and how to do that in a semi-manual way. Okay, so this is the container instance. I can export the templates. Okay, and I can deploy a custom template using this JSON, okay, through ARM, that is the engine that is providing resources inside Azure, okay? So I don't want to make things complex, so strip out the parameters. I want to create a container that is called like .22, but I want to create more than one, okay? So the syntax can be copy, and I need to give it a name, okay, to the copy activity, okay, just copy, and the count. And I could say 10, but the good thing is that you can use this as a parameter, push the parameter up, and save the template. So you can use the template to say, okay, deploy this template with these parameters, instance count, and also maybe the image. So we use that approach for long because we have like 100 containers, and we just click to deploy that containers with 50 instances, okay, to scale up more. In this demonstration, I will hard code these parameters inside the template to stay lighter, okay? But if I'm copying, so I'm iterating the provisioning part, the name cannot be the same because, of course, at the second time, the Azure can say, okay, but you already used that name. So we can use a trick. We can say concat dot the name, in this case, with a copy index. And this will generate a unique name for all the container instance. Okay. Well, this is nice. Image is .22. This is unexpected because I changed. Okay, server 22. I hope it works. The username is doc22 and the password is let's take it from here. Okay, really hoping it works. Let's copy it in the clipboard and let's deploy it. Okay. In the meantime, I'm creating some producer more, okay, just to increase the count here that is going up, then down. This is the active messages, okay. Let's really hope swear to it works. Okay, probably it's working, and the deployment is iterating to the 10 instances. So in like a minute, no, well, even less, okay, we are creating all these new container instances, and each one has the container, and each one is processing the message. Okay, it's waiting because because just a few seconds to start the container. I have no logs because the ratio of consuming is higher than the ratio of producers. Okay, so I can I'm opening some producer more in the backend part. Okay, so I open just this 7 producers. So I'm expecting to see something. Okay, now. Good. So let's close all of this and let's move on. So I also delete all the container instances that I created. Okay, good. Good. And now we are moving on. This is a good approach, but we need to govern the scaling path manually. So what I'm showing you now is container apps that does this automatically with the really elegant things and building blocks. Okay, so let's create a container app. Okay, this one. The environment run the container app and the underlying infrastructure deserves a session just for that. Not really a session, maybe a morning, okay, of a course. But now we are just focusing to some parts. So pardon me if I skip some interesting part in the wizard, in the menu, okay, but it's really complete to discuss it in just 5 minutes. So let's create again this container app in Western Europe, again, as usual. I don't want to use a quick start image, but I want, okay, okay, no registry found. Good, again. So again, I need to do this manually. The registry is private, login is top22.azurcr.io. Okay. Image and tag is consumer latest. Okay, good. And now we are locating a fraction of the CPU because we do not need it. We don't need a high CPU on several CPU to perform this work. But in case we can scale up to those sizes. If you remember the slide, okay, where I put the quadrant, okay, I wrote that container apps, in my opinion, is not really good from the scaling point of view at the time being, okay, because those sizes are not really complete compared to ACIs, and we can scale up to 10 instances as we are seeing later, okay. But apart from that, keep the focus on that service because it's really growing up fast. Okay. At this point, you can say, okay, it's pretty similar. Okay, ACIs, container apps, you just specify an image and probably in the next seconds it's running. Yes, but under the hood, container apps has an integrated Docker engine, so your container image can use Docker to communicate with other containers, to have state, to have all that interesting stuff. And last but not least, there's the KEDA, Kubernetes KEDA integration. KEDA is like Kubernetes event-driven architecture that let you implement triggers around events. Okay, for instance, which is the event I want to trigger in this demonstration? If you have messages in that queue, scale up. If you don't have messages anymore, scale down. And interesting things, scale down even to 0. ACI is just started or stopped, okay, and you just need to start and stop manually, okay, in case. With container apps, you can say, okay, listen to the queue, and if there are no messages anymore, just scale to 0 without spending a single dollar, okay. Well, it doesn't work good because of this registry, probably. Let's try to refresh. I will also open a new one. Probably it's a simple issue, but since it's really hard to debug it during a session, I'm trying to do it from scratch in a new browser. Well, container app name .22 again. Let's operate now. No registry found. Yeah. Okay. Again. Okay. Okay. So what I missed. Let's troubleshoot here. Where is it? Okay. The options is CR. Okay, okay. Not so bad. Not so bad. Okay. No, too much stuff. Image. Okay, good. I got the point. I'm retrying, hoping we have time to do this. Probably we have. So, okay, top 22. We can use this environment that's been created. We can use private endpoint, and as I got from the message, I don't need to specify the complete image name here. So we can just say consumer latest. For whom just joined the session, I'm debugging this creation part because in theory, I should have the integration between this creation part and the container registry that I create in Azure. Okay, I'm not so lucky today, so I'm just redoing it. I hope for the last time. Consumer latest name. Okay, finger crossed. And let's wait. Okay. What I was saying, about SCADA. So the really interesting part is container apps is integrated with this kind of events. So you can just say if you have messages, scale up, and if you have messages anymore, scale down to 0. Let's wait, I hope, a few seconds. Okay. A few seconds more. And in the meantime, let's go here. Container apps environment is good, but we are waiting for the container apps. Okay, good. Now we have it. So, as I said, it's not a short talk about all the stuff that we have in container apps, but we have the container we created, and we can scale it through custom rules. Before doing this, I need just a setting. Okay, I put in the secret part. Think about the secret part like just a repository of strings or settings of secrets that you can use inside the engine, inside the container apps environment. In this case, what I want to create, I want to take the connection string of service bus. Why? We will see it in a minute. With this setting here, I can reuse it in the scaling rules, okay? Where I can configure the scaling rules. Here, I can edit, so create a new revision of the application, because the interesting thing about container apps is it's working in revision. So when you publish the new container version or the new configuration, just creating a new revision and deactivate the old one. Really nice, because you can also balance the traffic. You can also restore an old revision. So you can perform that kind of stuff that if you're familiar, for instance, with Google App Engine, you can do as well. Okay, in this case, I'm creating a scaling rule. So the rule name can be service bus rule is custom, and this is to be filled with text. But if you go to the CADA documentation, you can see all the triggers that are supported. In this case, the type is Azure Service Bus, and to connect it, we can reuse the secret previously configured as the connection parameter. This will be injected inside the CADA rule to create the trigger. Okay, and we also need the metadata. Okay, two in that case, the queue name, queue name, that is messages, as far as I remember. Yes. Okay. And the message count used to scale up or down. So I want to say that with the 20 messages, the container app will scale up, and after under 20 messages will scale down. Okay, this is the good trade-off between the active message count inside the queue. Okay, let's create this revision. And in the meantime, I will start again the producers. So 1, 2, 3, 4, 5. Okay, I created them in my second screen. Okay, just to let you know. Okay, they are here. So now, well, if I go to log stream, I just say one instance, okay, that is receiving the messages. And nice thing, we have the log stream, not as I showed you in the ACIs. But if we wait some seconds, okay, we have many replicas because the trigger, the service bus trigger, fired and with Kedam, and the container app scaled to, in this case, 4. Okay, if we refresh again, probably no, 5. Yeah, good. So it's automatically. Okay, so after that, when in the meantime, I can close the producers. Okay, I'm expecting in few seconds, maybe a minute or so, that the scale will go down again, even to 0. Okay, but for this part, we need to wait around a minute or so. In the meantime, we can also monitor the well, too early, but we can monitor the trend of the active messages inside the queue, or even we can monitor the trend of the replicas. So in the container app, we can have a graph around the active replicas. So, okay, this portal today is giving me some nice, okay, replica count last 30 minutes. Okay, so we are seeing in real time that the replica starts with 1 and then is 5, and probably in a few minutes will go to 0 as the message count in the queue. Okay, this is just the starting point with container apps, but it's just I wanted to show in this demonstration. So the good takeaway is what I want you to keep of this session is that both container instances and container apps are serverless and are really useful if you don't want to manage all the stuff around Kubernetes and orchestrator. As you saw, we start from scratch. So we create a container and push it in the cloud. So it's really as you saw. Think about the container apps as a V2 of container instances, because it's the same engine, but we have log stream, we can have auto scaling, KDA, Docker, integration, and so on, and revisions. That is really nice. Also, we didn't cover in the session, but recent news are the idle mode. So if you have a container that is not consuming CPU, it's like in a idle state that will cost really a fraction of the current cost. And it's really nice because this can implement this kind of always running container with a low price. Then in case of activation, it will be billed with the normal price. So it's a nice and important feature. Also, you can expose HTTP endpoints. So we just saw a worker app, okay, at console application, but of course this container can also be with HTTP ingress. And that's all. So this is what I want to show you, and I'm here for the question right now.
All right, wonderful work there, Roberto. Thank you very much for that presentation. It's really
Thank you.
educational one. Um,
Thank you.
it looks like we have got one question coming in already. By the way, folks, if you aren't aware already, there is a tab for Q&A. Just enter your questions there, and then we can ask them now. We've got one from Valentinus who says, maybe I missed it, but is there an example published somewhere in Git repo that they can look to?
Okay, sure.
For the-
Thank you, Valentinas. The sample, of course, this part, so the demonstration in Azure is hard to get on Git, but in GitHub there's this folder of the conference with the slides and the code with the consumer and producer that I demonstrate in Visual Studio.
Okay, wonderful. There you go, folks. There's the information contained. Just trying to think if there's anything not covered. I mean, I felt like you gave it a pretty good run through. Just in the case that nobody else has a question at the moment, there are means to act like to contact you after this talk, right? Like you're free and
Sure.
open.
Sure. I'm here in the conference. You can reach me on GitHub. You can drop me an email. You can also ask for advices. So I'm really passionate about this. So feel free to reach me out where you want. Okay.
Yeah. That's
Good.
that's what I love is just how accessible everyone's being, including yourself, right? Like just that's what I love. It's not just a closed off talk. So, folks, if you do want to reach out to Roberto, you've got his links, you've got his contacts. Feel free to do so. I guess we'll wrap it up a little bit early. I'm sure some people are eager to get some food in their belly, as it is going to be an hour's break before we return for the next session. But honestly, Roberto, it's been absolute pleasure rather. Thank you for joining us, and I hope you have a great rest of the day.
Yeah, thank you, Darren. Thanks all the people that I see here in the backstage. So thank you very much and have a great conference ending ahead. Bye bye.